So we're in OpenStax Statistics, Chapter 12, and we're going to be doing some linear regression with CPI data. You can always access the OpenStax book for free. Just check in the description of this video for a link, and you can get a free copy of this Excel workbook at divideandconquermath.com. Just go to the OpenStax Statistics section. So the Consumer Price Index, or CPI, measures the average change over time in the prices paid by urban consumers for consumer goods and services. The CPI affects nearly all Americans because of the many ways it is used. One of the biggest uses is a measure of inflation. So by providing information about price changes in the nation's economy to government, business, and labor, the CPI helps them to make economic decisions. The President, Congress, and Federal Reserve Board use the CPI's trends to formulate monetary and fiscal policies. In the following table, X is the year and Y is the CPI. Okay, so we're being asked to do a handful of things for this. So first of all, we want to draw a scatter plot of the data. So no problem there. So I can pretty easily make a scatter plot. I can go to my recommended charts. I can come up with this scatter plot. I don't like this scatter plot because it's got everything connected. So I'm going to go into all charts and I'm going to go into this scatter, and I'm just going to take, sometimes Excel doesn't quite meet the mark on what it needs to do. So I have found the scatter plot that I wanted. So I'm just going to relabel this as CPI over the years. Okay, so we want to do just a least squares line for this. So I am going to just add a trend line. So I'm going to click on the dots and I'm going to go here to where it says add trend line. And so now it has created this trend line. Now you might also notice, and this is just something to kind of think about, so we are doing linear regression. There actually are other types of trend lines that you can put in. So you can see that there are options here. So just because we're doing linear regression doesn't mean that this is the best choice. It's just what we're working with in this particular chapter. And so when I set up my trend line, I also want to just put the equation and the r squared on the chart, and I'm just going to move that so that I can see it pretty easily. So now what I have here is I have my least squares line, I've got my equation, my regression equation in the proper form, and I've got everything on the scatter plot. So A, B, and C have all been answered here. But the next question says find the correlation coefficient. Is it significant? Now technically we could find the correlation coefficient from this r squared. But I need to also do now some testing on the correlation coefficient. So what I'm going to do is I'm going to use my data analysis tool to help me out with that. So I'm going to go under data and into data analysis. And very quickly, if you don't see this here, let me just tell you how to get to that. So if you go into file and then options, and then under your options, go here to where it says add-ins. And then from the add-ins, come down here to where it says manage, click go. Make sure that these two things are checked so that you can get to that data analysis tool. So I'm going to click on data analysis and I am going to select the regression tool. And this is going to do some testing for me. So I've already been playing around with this. So I have to select my Y's, and I have selected the Y labels. So you'll notice here I've checked labels. And then I have my X's. So I have my X's here. And again, I included the X labels. So that's why I've clicked labels here. For my output range, so I want to make sure I have output range selected. I want the output to go right here. So I click here and then I click on the cell that I want it to do. So I've got the output range. And then I'm also going to select the residuals and the standardized residuals. Actually, I guess we don't need them in this case because we're not being asked about outliers, so we can just ignore that. Okay, so I'm going to hit OK. And so here's my summary output. So as you can see, this gives me the same r squared as before, but it also now gives me my r. And so I'm being asked, is this r significant? And so what's interesting about this actually is that that answer is contained in this line down here. So you'll notice that I have all this different information. I have a coefficient, a standard error, I have a t-statistic, and I have a p-value, and then I have some other data here. So Excel just kind of automatically outputs so much information. They just give you the kitchen sink. But the only piece of information that you actually really need out of this is this little p-value right here. This is the p-value that will ultimately end up doing the calculation as to whether or not this r here is significant. And so as you can see, this p-value is pretty close to 0. And so just like any other statistical test, if p is low, the null must go. So this is telling us that, yes, this is significant. The correlation coefficient is significant based on the p-value. And the final question here is, what is the average CPI for the year 1990? So as you can see, I don't have 1990 as a year here, so I can easily compute that. So I'm just going to put in x equals 1990 into my regression equation. And so as you can see, I can either use this regression equation here, or I can have that, like here I've got the slope and the y-intercept. These are the same numbers as what's in here. So however I want to do this is fine. But what I'm going to do is I'm going to have, so let's see, I'm going to take my x times 1990 plus my y-intercept. So I just used these here. I could have hard typed that in too. And so it says here in 1990, my CPI would have been 140.6. And so that was the last question.